So this will be my last constant acceleration problem I do with you, where it's just focusing on constant acceleration. But let me comment on this. This was another exam problem. It was in the previous version of this course called APSC 1023. And in that course, we also dealt with impact, which is not part of this course. That actually lands in the next course, dynamics, for the ME students. So this is not a viable problem for this course, but it was a problem that, again, was an unmitigated disaster on the final exam. But I think we can understand it. So the part that I can't give you in the future would be an impact problem, all right? But you've seen this, actually, hopefully you would have seen this in your high school class in physics, and in Physics 1081. You would have seen this. So this is really basic stuff. And so we have a concept here called the coefficient of restitution. You can see that in this problem, and the coefficient of restitution between the ball with the concrete wall and with the slab is 0.8. All right, so what I have here is the ball is coming in at 20 feet per second. There'll be an impact, and due to the coefficient of restitution, it will come off more slowly. So to get when it comes off, which it will do, all right, it goes in horizontal, it'll come off initially horizontal, and we simply multiply by the coefficient of restitution. So it's coming off at 16 meters per second. All right. And so I think you're familiar with that. Now at that point, it's going to come in, and somewhere out here it's going to hit. So state 1, it's coming in. State 2, it bounces out. State 3, it hits the ground. For me, state 4, it comes up. And the question is okay, how far, determine how far the first bounce is from the wall. So I need this distance along the x. And then it says, what's the height of the first bounce? So that'll be state 5. And then I'll need that y. Okay? Now, when it comes into bounce, the coefficient of restitution will be along this y. So once I get the y component of it hitting, I take the y so whatever the x is as it comes off, we're in a vacuum. It just 16 meters per second constant, never changes. But it's going to develop a y velocity coming in. When I find out how fast it hits here, I use this coefficient of restitution, and the y component coming up is whatever it is coming in times 0.8. And we get it coming out. So that's the piece of the problem that is not technically part of this course. I will not put that on an exam. But we can do the problem. And again, I'll have you assess, is this a crazy problem? So we know how it's coming off. And so step 3, we'll go, what I need is to figure out where it hits. All right, so let's just start breaking that down. So to get to state 3, that'll be distance 3 in the x, 3 meaning state 3 to get there, which will be nothing more than this velocity times time. 16 times t. And notice the coordinate system. So that says this velocity is negative. So we're just watching my sign. So this will be in the negative x direction. That's fine. So as soon as I write that down, I go, I need time. Well, how can I get time? Well, the initial velocity coming off here is 0 in the y. I know exactly how far I'm going to fall. I know exactly acceleration. So if I look at my situation, I know acceleration, I know distance, I can get time. So that's what you always do in these problems. Say, okay, acceleration, okay, got constant acceleration, what other parameter do I know? And then I back out. Then I use one of the equations to give me a third component. So it's going to fall 2 meters. So minus 2 meters. I'm going to call this a 0 reference for right now. So this is minus 2 relative to that. That's fine. plus 0t, initial y velocity is 0, plus 1/2 minus 9.81, because I'm in meters, t squared. Solve for t. T equals 0.639 seconds. Therefore, dx3 equals minus 16 times 0.639, which gives me minus 10.22 meters. And the first part is done. You have no idea how few people got that far. I don't remember the numbers, but a massive portion of the class did not get to there. Not good. All right. But I must say, if you can't do this, okay, granted this isn't fair for this class, but putting that other than that, if you can't get to there, I don't think it's my fault. I think it's the students are just not taking this seriously. All right. So I've answered this. Now I've got to get the height of the first bounce, so I need a lot of information. I need to know now, I know where it hits, I need to get the velocity coming in right here, so I can multiply it by 0.8 to get the velocity here, and then I'll work towards this back piece. All right? So what I need now is this y velocity. So I need v3y, okay, coming in. So I'm going to just ask, what do I know? I have acceleration. I have distance I'm going to fall. I know the initial velocity at 0, it's boring. I want to get v out of that. Okay, well that's easy. v3y squared equals v2y squared, which was of course 0, the initial velocity here in the y, plus 2 minus 9.81 times 2 meters, the distance we're going to fall. Bam. So for this, sticking that in there, we get v3y, taking the square root, and taking the negative portion is minus 6.26 meters per second. Now, I'll note we could have done this another way. We could have taken the note that we had acceleration and we had time up here. So we could have gotten v that way. Now that would be v3y equals v2y plus at. Of course, this is 0. That's minus 9.81. That's 0.639. Get the same answer. Again, so very easy to get there. So now I know this piece. So now the next thing I need is I need v4y. How does it come up? Well, that's simply v3y times minus 0.8. Whenever you use the coefficient of restitution, there's a sign change because you're going one way, now you're going back the other. Okay, fine. So that leaves us with 5.01 meters per second. All right. So now let's see what we know. I know going on, I got to get how high this is. I have acceleration. I have initial velocity coming off. I know the final velocity because this is at the peak. How high is the first bounce? So I know A, I know V, I want D. Oh, well that's just flipping around this equation we just used. So if we go knock that off, v5y squared, which will be 0, equals v4y squared plus 2 times A, which is minus 9.81, times that height. v4y, 5.01 squared, one unknown, solve for D, come up with 1.28 meters. And that second part of the problem is finished. Once again, just have to go through. Always keep going, start from what you know, and then what I do here is finding the things I knew. I use one of the equations to get something else, to get the third thing. In this case, I got time. Then once I had time and distance, I could get velocity. Then I bounce over here by coefficient of restitution. Then I say, okay, what two things do I know? I know velocity, I know acceleration. Bam, I get distance. And if I wanted to, I could have gotten the time to get there as well. Just different equation, very straightforward. With that, we're going to move on to curvilinear motion, and we'll talk about that shortly. Bye now.